name is George Bridgers, and I work with the North Carolina Division of Air Quality, and I'm a senior meteorologist slash air quality modeler and forecaster here with the division. And I've been with the division somewhere around 12 and a half years now in this role, kind of seeing the growth of air quality forecasting from what I would consider its infancy back in the late 90s through a much more mature process that's done throughout the country now. I wish there was a typical day, and that's one of the things I really like about my job. Actually, the primary role that I have with the state of North Carolina is compliance with the Clean Air Act. And so there's this federal Clean Air Act that the EPA, the Environmental Protection Agency, has congressional mandate to follow. And the states and some local governments take it upon themselves to make sure that their state or local municipality is in compliance with that Clean Air Act. And there's various pollutants, at least in the world that I work within air quality, called criteria pollutants. And if we're in violation of one of the criteria pollutants, I play the role of helping to do projective computer modeling, environmental forecast modeling of future scenarios to see how we can come back into compliance. You know, what type of strategies, emission reduction strategies that we can do to come in compliance with those standards. Probably most folks that are listening to this will have heard of like ozone or fine particulates, and there are a few others. Lead, they took out lead out of gasoline back in the 70s or 80s. Nitrous oxides, SO2. But nonetheless, ozone and fine particulates are generally the ones that you hear the most about, and those are the ones that we forecast for. But at any rate, when part of North Carolina is in violation of that ozone standard or the fine particulate standard, then we work with other engineers here to come up with various emission strategies that is, how do I put this, not overly restrictive on industry and not overly burdensome on the public. So here in North Carolina we have an emissions testing that's done on vehicles, and that's part of this air quality program. The power plants here in North Carolina in the last half decade have had to put on over $1 billion in controls, and all of this came about with looking at what types of strategies that we could build to lower ozone and fine particulate levels, and a few other of those criteria pollutants, but most focused on ozone and fine particulate. And we've had a lot of success, and that's good. That kind of gives us a redeeming factor that the work that we do ultimately, comes toward a common good without driving the electric rates up too high or making it too onerous on like automobile owners. But our group on a large scale does all of the air quality permitting in the state. So pretty much any facility industry that has a smokestack and has some sort of effluent stream of gas out into the air, they have to seek an air permit. And again, the meteorologist role kind of comes back into the forward planning aspect of it. And because we were looking at these projections and using computer models like WRF and MM5 and from the air quality side, CMAC and CAMEX, they're just kind of catchphrases there, are acronyms for the models that we use. But since we were already using that sort of a prognostic look at the future, the thought was back in the late 90s, well, what happens if we, instead of looking multiple years out in the future, let's just look a couple of days out in the future? And that's where we kind of got brought into doing air quality forecasting. So instead of a decade of look out, we're looking at 2 to 3 days at the most. And largely the air quality forecasting community is probably in the 80s now as to where the rest of the weather community is. The big issue that we didn't have until probably the last 5 years was the prognostic forecast models specifically forecasting the pollutants. We had the weather models that we all use and love, but we didn't have the one that added on the chemistry that was very reliable. And that's something that with the increase in computer capacity that we've come up to speed on now. And so we're making strides toward being a very technologically savvy forecast program. And I say that from North Carolina's perspective, but this is the same whether we're talking about California or Shanghai or Tokyo. We're all sort of in the same boat where the science is evolving around us as we go along. But back to your original question, what's a typical day involve? It could be working with the governor's office or the attorney general's office on some rule or issue with non-compliance or non-attainment with the EPA's Clean Air Act. It could be issuing forecasts, say there's a large forest fire or some large air quality event. that's going on, reacting to that. We do a lot of data analysis of the actual air monitoring data. We have a whole group here within our division that collects all this air data. And one of the things is, what do we do with the data once it's collected? And the meteorologist, because we're already naturally doing all this other evaluation of environmental parameters, we kind of have taken it upon ourselves to add on this extra aspect of doing the day-to-day data analysis. And it, again, kind of full circle, comes back to our forecasting. It helps improve our forecasting when we're looking at the data. So every day is different. Makes it exciting. And then we also, I guess I didn't mention, that we also operate some equipment out in the field. We have 2 lower tropospheric radar profilers, and they're basically just vertically pointing radars that give us continuous wind speed and wind direction up, say, through the lowest 2.5 to 5 kilometers, depending on the atmospheric conditions. So we can see up regularly to, say, 5 kilometers, but we can almost guarantee 2.5 to 3 kilometers every day, every half hour. And so occasionally they need maintenance. So we may have our jeans on, or and our steel-toed boots, and we're climbed underneath the bottom of a piece of equipment. So it's some inside work, or a lot of inside work behind computers, but sometimes we're out in the field. It's kind of all over the place. One is in Charlotte. It's actually at Charlotte Douglas Airport. They make a lot of noise. Well, I say they make a lot of noise. They're actually very quiet. It's a 915 megahertz radar. So that part is silent, but there's an add-on part that gives us virtual temperature for the lowest kilometer, and that's an acoustic sounder, and it's very loud, 120, 130 decibels, and it sounds almost, I don't know, think of crickets on all sorts of steroids and loud PA system. But nonetheless, it's very annoying, and so to put it in an environment like an airport works okay, because you've already got a lot of jet noise. But the other profiler is very near Raleigh, and it's out in the middle of nowhere. And so far we haven't had too many complaints from the neighbors. But anyway, they're in 2 strategic locations based on where in North Carolina we have some of our worst air quality problems, because we really need to understand the structure of the atmosphere over, say, Charlotte during a bad air quality day. And so understanding the 2-5 knot winds, sometimes pushing 7-10 knot winds, understanding that flow vertically throughout the day is extremely important. And we just don't get that from the radiosonde network. And there is the VAD, the vertical display that you get from the WSR-88D, the Weather Service network, but they work off of hydrometeors. They need reflectivity, and our worst air quality days generally are clear, sunny, somewhat dry atmosphere, and so the 915 radar that we have is tuned to see different, it's actually looking at turbulence, and in the turbulence of the atmosphere you'll see the microscopic dust particles, and that's what it's seeing. So it's tuned to that, versus with like the Weather Service radar where it's looking at hydrometers or raindrops. And so we really need this special piece of equipment to understand the atmosphere, unless we want to go out and launch a bunch of balloons all the time, which would be fun, but rather expensive.